Hi, so long time no see, and this is the R class for chapter 5, whose name is sampling distribution. So, as you already know this kind of concept, sampling distribution, we are going to practice some knowledge or practice some situation in dealing with the sampling distribution. So, as you already know, the sampling itself is a very popular thing in statistics because we always make an inference from the sample about the population parameter. So it is actually a very important concept for dealing with when we're dealing with um, statistics. So there are some examples in this material, so we will solve some problems with throughout our programming. Then I will assume that you already know about all of these kind of notions, and let me just start with example number 3. So actually, the most important thing is that if our population follows the normal distribution, our sample mean also follows this kind of normal distribution with a similar parameter, which is mu as a population mu. It is same to each other, and then the variance is the sigma squared divided by the n, in which the sigma squared is from the population distribution. So make sure that when our population follows the normal distribution, our sample mean follows the similar normal distribution with the similar parameters. So then you can see that it also asks us about the distribution of the sample mean, which is very easy. So this part is for example number 3. So we already know that the sample mean follows the normal distribution with the parameter mu, which is the same as the population mu, and also the variance, which is the this thing. So A solved now, and then the probability that our sample mean is greater than or equal to 138. And because we already know the sample mean, the mean and variance of the sample mean, which is this one, mu is same to the population mu, and the variance is the same as the square root of the standard deviation of the sample mean. It's the square root of the variance divided by n from this information. So because we are dealing with the probability when our target variable is greater than or equal to, and it is same as the 1 minus probability when our target value is less than 138. And as you already know, when you calculate this probability, we use the p-norm because x bar follows the normal distribution. So, and also you have to also make sure that when you're using p-norm, because we are dealing with the left side probability, you have to use the the default value or the tail option. So you can see that there's nothing I set as the tail option. So I just calculate the probability by deducting the result of the p-norm from 1, which is the after storing the value, which is the 0.02. That's it. And so actually central limit theorem guarantees that even though we start from the other distribution like uniform distribution or exponential distribution, as we observe the distribution of the sample mean, we always find out. So, and it always lead to the normal distribution. The distribution of the sample mean is always goes to the normal distribution when n increases, even though we started from various distribution. So this is the most important thing actually in statistics. So because this is just the introduction statistics, what you have to do is just admit this phenomenon and accept the theorem without any I mean without any doubt. So central limit theorem is what it is here. It says the distribution of the sample mean when n is enough large. And let's delve into the example number 6. So it gives us the population mu and population variance, and it says that we are dealing with a sample, and sample size with n is 64. So it asks us about the probability when the sample mean is between 78 and 85. As you already know, we can calculate this probability by deducting the probability of when x bar is less than or equal to 85 minus the probability when x bar is less than or equal to 78. So this is each term can be calculated from the p-norm function in our programming with these parameters. So this is the answer I prepared. This part. So mu is 80, population mu. So this is for population information. And because we are dealing with a sample distribution, you always have to use the mu as the sample mean. I mean the mean of the sample mean. And in the variance part, you have to use the result or the square root of the variance, population variance divided by the sample size here. And this is the formula I wrote here, and I implemented this this statement with this code. So after running this code, you can see that the value is about this one. And the problem B is that what if the sample size is 100? It is very easy. So because what you have to do for now is just modifying the sample size. So just change the sample size value into 100 and run the same code again. And because we have the different value of the sample size, we get the different, oh sorry, I didn't store this value. So with the sample size 100, you can get that the same code with a different probability, which is about 0.95. This is the answer of the example number 6 here. And let's go to the this final part, which is the sampling distribution of proportions. So actually, when you are dealing with the sample mean follows the normal distribution with the population mu and the sigma squared divided by sample size, and sigma squared comes from the population variance, and this n comes from the sample size, and this mu comes from the population mean. However, when you are dealing with the population proportion, I mean the sampling distribution of proportion, which is the sample proportion, you have to make sure that it follows this distribution. So it is same that it follows the normal distribution, but yeah, here it follows the population proportion. The sample proportion mean also follows the normal distribution, but different with the different parameters. So its mean, its expectation is P, which is the population proportion, and for the variance part, we use this term, which is the P multiplied by 1 minus P divided by sample size. So we only need just one information, which is a population proportion. And then we can get the exact distribution, the limiting distribution. You don't have to worry about that. The distribution, anyway, of the sample proportion mean with only the one information, which is P, population proportion. So chapter 7, I left this part with exercise, so I skipped in my code in my R program file. And let's delve into the example number 8. So we know that our obesity rate is 0.3. So we know that the population proportion is already 0.3. And the sample size is 50 here. And then it gives us it says that we are dealing with the sample obesity rate, so we are dealing with the p bar here, and the probability when the p bar is greater than 0.2. This is what you have to calculate for now. And this is same as the 1 minus the probability when our p bar value is less than or equal to 0.2, because it is more convenient for us to calculate the left side probability when you're dealing with the normal distribution with the p known function in our programming. So this is what it is. So nothing but just calculating this value with the p known function here. So we already know the population proportion and sample size. So we know that our sample proportion follows the normal distribution with the mean as the same as P, and the variance as the same as this value. So we can put the mu and square root of the variance value here from after calculating the parameters, and just deduct the result from the p-known function from 1, so that we can get this value, which is the answer. So you can see that for this part, this is the answer. And the next question is that the probability between these two values, which is also easy. So this is the same as this probability. And actually, this is the same as the previous one. Maybe here. So you already know how we can solve this problem. So actually, this can be also applied to the methodology can be also applied to this problem. So this is the answer for solving the problem, and you can get the answer as the 0.92 about. So this is what I have done in this practice. So actually, this is very easy. What you have to remember is that even though we start in any distribution, and even though we start even any anonymous distribution, our sample mean always follows this value, this distribution. And our sample proportion always follows this distribution. So because if we know the mu, and I mean the mean and sigma. I mean, if we know the mean and variance of the normal distribution, we always can calculate the d norm or p norm or q norm or r norm function in our programming. So actually, getting the each parameter is the most important thing, and it is also not difficult. So I think there is nothing difficult in this practice today. I believe in that, and actually there's more part, but uh, I will explain this another part after explaining in, yeah. Okay, let's go to the another part now. Then I will explain in Korean the whole about the whole class today. And actually, there's no content about this R code in our class material, but this is also this is nothing but just a experiment in which we can check the result of the CRT, which is the central limit theorem. So from this part, you don't have to understand all the thing, and you don't have to memorize all the thing from this part. So if you are not, if you have difficulty in understanding or learning this part, I think it is okay that you dismiss or you pass or you skip this part. Anyway, I will briefly explain about this part. And actually this is, we are just repeating the same experiment with the different sample size so that we can check the relationship between the sample size and the power of the central limit theorem. Actually, central limit theorem is nothing but a theorem that even though we start from any distribution, it always leads to the normal distribution, the sample mean. So we are going to check if the sample mean really goes to the normal distribution. So this is actually the, I just plot a normal distribution, which is the mu as 5 and the sigma squared as a 4, the variance. So we can start with the samples, the experiment with the sample size 2. And as you already know, R-norm function is a function which gives us the random sample from the normal distribution. So it means that we are going to have the 2 random sample from the normal distribution with these parameters. And then with the mean function, we can get the expectation, the mean value of the 2 random sample from the same normal distribution. So if we run this code once, we always get each value different time. So actually this is the same as the sample mean, just the incidence from the experiment from the normal distribution. So if we repeat this this kind of getting sample mean, we can see the distribution of the sample means. So this is what we are going to do from now on. So this is the code for making an empty vector here, whose name is normal x bar. So we are going to store all the sample mean in this vector. So it has the non-available thing, which is the, I mean, the empty thing. So we are going to make a vector which has 500 empty thing. This is the repetition function. So you can see that normal x bar has 518, which is the empty, which means empty one. So please ignore this part. So we can store all the sample mean with this assignment operator in our the first location of the our own vector, second or third, and or even the 500th location of our own empty vector. Then you can say that we store the sample mean from the first and second, third location, and the last location of our empty vector. However, if we want to store all the value 500 times, we have to repeat the same code 500 times. So in this situation, the for loop is what we need. And I know that I already taught you about the for loop, which help us to repeat the same experiment with different I value. So it means that we start with the I from 1 to 500. We store each sample mean in i's location of our empty vector. So we can simply store 500 sample mean into our empty vector. And let's check the normal expo again. And it has 500 sample mean now. So this is just for plotting our normal x bar to see the distribution. So you can see that it has some distribution, but it is not at all. So we cannot say that this is enough good normal distribution because the sample size is too small, which is 2. And however, if we increase the sample size up to 10, let's see the same thing. So you can see that with the sample size 10, you can see that it seemingly follows the normal distribution. And let's just skip the 50 part. And how about what if the sample size is about 100? Let's do 500. Then maybe we can change this part here. So you can see it's too tall. Then let's get back to the sample size as 100. Then you can see that it follows the sum normal distribution. So you can see that as we increase the sample size, you can see that the sample mean. Actually, this is the distribution of the sample mean, not sample, which is x bar. So you can see that this is kind of normal distribution. And you can also check if the mean and standard deviation of our sample mean follows the same formula, which is this one. Yeah, mu and sigma squared divided by n. So I prepared this code so that you can compare each result to check the theoretical thing here. And the second part of the CRT is that nothing but just we do the same experiment with the different population distribution. So in the first part of the experiment, we started from the normal distribution and check if the sample mean follows the normal distribution. However, as CRT always guarantee that we don't have to start from the normal distribution, in the second part of this code, it starts with a uniform distribution, not normal distribution. So this is what it is, what uniform distribution is with the 2 parameter, the mean and max thing. And the other thing is the same as the previous one. So I always make the sample mean with the mean function and our unit function, and make a sample mean and store each value 500 times and check if the sample mean follows the normal distribution. So this is what the graph is when the sample size is 2. However, if you check that the sample size, when the sample size is 100, you can see that sample mean has a normal distribution with this mean and this standard deviation value. So you can check and compare to the result to the theoretical thing with the CRT. So yeah, that's it. So if I can say again, from this part, which is about the experiment about checking if CRT works, if you have a difficulty in understanding, or if you have difficulty, or if you don't want to if you don't want to learn, actually I think you can also skip this part, because this is just an experiment for your understanding, for better understanding. However, the previous one with this example is very important, because this is all about what sampling distribution is, what sampling distribution follows. And based on the knowledge, we can calculate the sampling distribution probability based on the CRT. So this is the end of class, and after summarizing the lecture in Korean, I will end up this class. Thank you. 네, 안녕하세요. 그래서 사실 되게 간단한 파일인데요. 오늘은 좀 길게 설명한 감이 있는데, 샘플링 디스트리뷰션을 이 뭔지 고르는 거잖아요. 근데 그럴 때 결국 CAT가 중요하다는 건데, CAT가 진짜 작동하냐는 이 코드를 통해서 그냥 실험적으로 알 수 있는 거예요. 그게 왜 진짜 수비적으로 작동하는지는 통계학 입문에서는 배우지 않습니다. 그렇기 때문에 사실 고등학교 때도 이미 배웠듯이 샘플 수가 많아질수록 어떤 분포에서 시작하든 표본 평균은 항상 노멀 디스트리뷰션에 따른다는 거죠. 그럴 때 파라미터들은 샘플 민이 다를 땐 이 파퓰레이션 뮤나 파퓰레이션 베리언스를 n으로 나눈 값, 혹은 샘플 프로포션을 다룬다면 이 값을 따르니까, 어차피 저희는 노멀 디스트리뷰션을 다룰 때 민이랑 베리언스 값을 알면 덴시티도 구할 수 있고 R 놈을 통해 뽑을 수도 있고 다양하게 할 수 있잖아요. 그러니까 이전에 챕터 3, 챕터 4에서 한 거랑 똑같다는 거죠. 대신 샘플링 디스트리뷰션이니까 문제에서 우리가 샘플을 다룬다 하면 이제 파라미터를 잘 구하셔야 된다는 겁니다. 근데 그렇게 어렵지도 않아요. 그리고 항상 설명했듯이 피논 펑션을 쓸 때 이게 디폴트 밸류가 로얼 틸 옵션이었나요? 그게 false잖아요. 왜냐하면 레프트 사이드이기 때문에. 그래서 만약에 x바가 특정 값보다 크거나 같은 확률을 구하려면 피놈을 1에서 빼줘야 된다는 거죠. 로얼 테일 옵션을 디폴트 값으로 쓴다면. 뭐 그런 거는 이미 다뤘었고, 하여간 이미 앞에 내용을 잘 숙지하고 계신다면 하나도 어려울 것이 없다고 생각을 합니다. 그리고 아까 영어로도 말했듯이 CAT 이 실험하는 부분은요, 결국 똑같은 실험을 계속 반복하는 건데, 샘플 사이즈가 커질수록 진짜 이게 노멀 디스트리뷰션을 잘 따르고, 아니면 미니나 스탠다드 디비에이션을 비교해봤을 때 저희가 앞서 다뤘던 이런 값들이랑 잘 맞아 떨어지는지 그냥 비교를 하는 실험이어서 쭉 돌려보면서 확인해 보시거나, 아니면 하고 싶은 실험 있으면 이것 좀 바꿔서 해보시거나, 그것도 싫다 하면 그냥 제 생각엔 넘어가셔도 될 것 같습니다. 이걸 가지고 막 SEQ 함수가 뭔지 막, 아니면 뭐 팔루프를 어떻게 짜야 되는지 뭐 그런 게 사실 중요하지 않거든요. 전혀 통계학 입문이기 때문에. 그래서 그냥 이런 걸 확인하는 실험이구나, 아니면 이런 코드들을 이용해서 실험을 짜볼 수 있구나 한다는 점을 아시는 게 중요하다고 생각이 듭니다. 그러면 다음에 뵙겠습니다. 감사합니다.